Imagine you have a massive amount of data, far too large to fit on a single server. What do? Storing all this data on one server isn't feasible, and it can lead to performance bottlenecks and potential data loss. This is where data partitioning comes in. It's a technique that helps manage and organize large data sets efficiently. It involves breaking down your data into smaller chunks and distributing them across multiple machines. This not only improves storage capacity, but also enhances data retrieval speed. This way, you can store more data and handle more traffic. By spreading the load, you ensure that no single server is overwhelmed, leading to better performance and reliability. Traditional hashing methods, like modulo operations, can distribute data. These methods are simple and effective for static environments, but they struggle when you add or remove servers. The entire data distribution can become unbalanced. Suddenly, almost all your data needs to be remapped, causing significant disruption. This can lead to downtime and inefficiencies. This is where consistent hashing comes in to save the day. It minimizes the need for data remapping, ensuring a smoother and more efficient data management process. Consistent hashing is a special kind of hashing algorithm that plays a crucial role in modern data distribution systems. It is designed to minimize data movement when the system undergoes changes, such as adding or removing servers. Instead of relying on the number of servers, consistent hashing uses a virtual ring structure to manage data distribution. Each server is assigned a specific position on this virtual ring, creating a seamless and organized system. When you need to store data, it is hashed to a particular point on the ring, ensuring a precise location. The data is then stored on the server that occupies the next clockwise position from the hashed point. This method ensures that data is distributed evenly and efficiently across all available servers, preventing overload. The beauty of consistent hashing lies in its resilience to change, allowing the system to adapt smoothly to new conditions without significant disruption. Imagine the consistent hashing ring as a clock face, where each hour mark represents a server in the network. Each server is like an hour mark on the clock, positioned at specific intervals around the circle. Data, after being hashed, is assigned to the nearest clockwise server, ensuring an even distribution across the network. When you add a new server, you're essentially adding a new hour mark, which helps in balancing the load more efficiently. Only the data between the new server and the next one needs to be moved, making the process quick and efficient. This means minimal disruption and easy scaling, allowing the network to grow seamlessly without affecting performance. Similarly, removing a server is like removing an hour mark from the clock, which simplifies the process of decommissioning hardware. Data from the removed server is simply taken over by the next server on the ring, ensuring that no data is lost and the network remains stable and reliable. Virtual nodes, ensuring even distribution. While consistent hashing is great, it can sometimes lead to uneven data distribution, especially with a small number of servers. This is where virtual nodes, or vNodes, come into play. vNodes are essentially virtual copies of a physical server. Each physical server is assigned multiple vNodes, distributed randomly on the ring. This creates a more balanced distribution, even if the number of physical servers is small. Using vNodes ensures that data and load are spread more evenly across the physical servers in the system. Conclusion: the power of consistent hashing in a scalable world. Consistent hashing is a powerful technique for distributing data in a distributed system. It offers several advantages over traditional methods, including minimized data movement during scaling, as adding or removing servers only affects a small portion of the data. Improved availability, since data is replicated, so the system can tolerate server failures without data loss. Enhanced performance, with load distributed evenly, preventing bottlenecks. These characteristics make consistent hashing ideal for systems that require high availability, scalability, and performance. Consistent hashing in action real-world applications. Consistent hashing is not just a theoretical concept. It's actively used in many real-world systems, including Amazon Dynamo, a highly available key-value store that uses consistent hashing for data partitioning and replication. Apache Cassandra, a distributed NoSQL database that uses consistent hashing to distribute data across its nodes. And Memcached, a distributed caching system that uses consistent hashing to map keys to cache servers. These examples highlight the effectiveness and widespread adoption of consistent hashing in handling massive amounts of data and traffic.